Good afternoon. My name is Luisa Velasco. I'm presenting my final for the Data 605 Fundamentals of Computational Mathematics. Let's dive in. For problem 1, probability. So we generate a random x variable that has 10,000 random uniform numbers from 1 to 6. And for the y, we selected a random variable with normal numbers having a mean and standard deviation of teka lang, Good afternoon. My name is Luisa Velasco. I'm presenting my Data 605 finals for computational mathematics. For problem 1, we generate a random variable that has 10,000 random uniform numbers as x, and we selected for the y a random variable that has a random normal numbers with the mean and the standard deviation of 7.5. So the layout of them both are on this screen, x being uniform and y being normal. No. Good afternoon. My name is Luisa Velasco. I'm presenting the final for Data 605 Computational Mathematics. For problem 1, we have two sets of variables. We have x and y. X being the uniform numbers between 1 to 6 and having 10,000 numbers. And for y, we have a random normal numbers having the same mean and standard deviation. Histogram for both of them are laid out in the screen. And for the small x, we have median. And for the small y, we have quantile, the first quantile. And I set up a couple of variables for the probability and for the count of each number, being x greater and less than equal, greater and less than equal for y, and also the count of each corresponding probability. We use the conditional probabilities of A and B equals the probability of A multiplied by the probability of B given A. So for the three probabilities below, we have first the probability of x greater than small x given that y is greater than the first quantile. We have 0.05. The second, the probability of x and y. We have 0.375. And the third is still like the first one, but this one is less than. So we have the same probability of 0.5. So next section is we'll investigate whether the probability of x and y is equal to the probability of x multiplied by the probability of y. And for x and y, we have 3.75 as calculated above. And for x being greater than the median, we have, sorry, Good afternoon. My name is Luisa. I'm presenting my final for Data 605 computational mathematics. For problem 1, we have two sets of variables. We have variable x being uniform numbers between 1, 2, 6. And for y variables, we have random normal numbers with mean and standard deviation equals to row count plus 1 divided by 2. In R, we have this set up as this using the runit and R norm functions respectively, and below shows their histogram, uniform and normal. And for the probabilities, we have a small x being median of x and small y being first quantile of y. I have set up a couple of variables to store the probabilities of greater than x and less than or equal to x, which is the median, and greater than y and less than or equal to y. So I also correspondingly set up a couple of variables for the count. For the probabilities of A to C, we will use this conditional probability formula, saying that probability of A and B is equal to probability of A multiplied by the probability of B given A. So for the first one, we have the probability of x greater than the median given that y is greater than the first quantile. That comes out to 0.05. The second one is the probability of x greater than the median and the probability of y greater than the first quantile is 0.375. The third one is like the first probability, it's just that this one is less than x, it's less than the median. It arrives at the same calculated probability of 0.5. So the next section investigates for independence. Using this formula, the probability of x and y is equal to the product of probability of x, probability of y. So from the above computation, we have the probability of x and y, which is 0.275. And then the single probability of x being 0.5, single probability of y greater than the first quantile is 0.75. So if we use the formula, we will find out that these probabilities are equal, which gives us the independent event, x and y are independent events. We use the Peters and exact and chi-square to test it for the association. And when we created that, we have, I got it to the same p-value of greater than 0.05, which suggests no association between x and y. For the problem 2, we have the Kaggle data set for house prices. So for the train data set, we have 1,460 observation with 81 variables, including the sale price, which is a dependent variable. We have a combination of categorical and numerical variables, and we presented a summary of each one. And for the second item on this problem, we have a scatter plot of two independent and dependent variables. I chose the lot area and the ground grade ground living area square feet, and the sale price being the dependent variable. And I have a plot of the lot area versus sale price and a plot of living area and the sale price. So then we have the correlation matrix. I use the overall quality, overall materials and finish of the house, the garage area and the sale price, and created a correlation matrix. And did a hypothesis, alternative hypothesis being there's no correlation, and a null hypothesis that there is zero correlation. At 80% confidence interval, at pairwise, I arrived at each one having less than 0.05 p-value, and for this I can reject the null hypothesis if there is no correlation between them, and looking at the correlation matrix, there's relatively strong correlation between them. Linear algebra is I have to invert this correlation matrix and then multiply the inverted matrix with the correlation matrix. I got one on diagonal, and I decompose this inverted matrix to have the L and U parts. And when we multiply the L and U parts of it, we arrive back at the inverted matrix. For the calculus part, we have selected a speed variable. I selected total basement, and then I transformed this variable, put it in the X. I added the one for each variable to shift it above minimum of 0, and we did an exponential probability and lambda and get 8,000 samples. The histograms of both the empirical and the exponential, and we calculated the 5% and 95% quantile of the exponential and the empirical, and the confidence interval of the empirical 95% interval. And for the modeling, I've used stepwise regression and only used the numeric variable for this one. And I only included complete observations, and I trimmed the outliers at 5% and 95%, bottom and top respectively. And this first I did a complete model, and then I did a step model both forward and backward, and then all the variables have p-values. It's alright. They include in the model the diagnostic plot synthesizes a decent model, and from this I predicted the sale price and Submit Chicago with a 0.20 score. This is my Chicago research. Thank you very much.